Join us on a voyage through the wormhole, your gateway to groundbreaking thinking on AI, space exploration, a healthy planet, and a more intelligent future. I'm your host, Jonathan Knowles.
The Wormhole is produced by Trillium Technologies, leading the application of artificial intelligence for planetary stewardship, space exploration, and human health. Help us explore what's over the event horizon by following us on LinkedIn and Twitter at trillium.tech. Together, let's build an intelligent future.
Hello, and thank you for joining us as we explore the domain of heliophysics in this Wormhole series. NASA has designated 2024 as Heliophysics Big Year, and we are featuring scientists who are at the very forefront of unraveling the mysteries of our very own star, the Sun, and its profound effects on space weather and Earth's climate. FDL has been engaged in heliophysics research for 7 years, and we're so fortunate to hear from these scientists. All of them are FDL faculty who bring a wealth of knowledge and experience, as well as groundbreaking research that has significantly advanced our understanding of solar phenomena and the impacts on the solar system. Our sun. What a thing. We look up at that great fireball in the sky almost every single day when we're fortunate enough to be able to see it. And who doesn't love seeing a sunrise over the mountains or a sunset on the beach? And for those of you who have been fortunate enough to see the aurora borealis and marvel at what the sun is causing in our atmosphere, it enables life on our planet. We marvel at other things that it does. And we'll be talking a little bit about this a little later on. We incorporate it into our art, into our literature, and we have built entire cultures around the sun over thousands and thousands of years as humans. We even have sun worshipers to this day. Not only will we peel back the layers of our star during this 3-part series, we will look up close and personal at some of the truly astonishing things that it does. We'll explore new ways of seeing our sun thanks to various technologies. We, of course, know that it provides modern things such as electricity to us with solar panels. It is a primary driver in what is happening with regards to our climate here on planet Earth. It's doing some other things that I think you may be surprised to learn about. We will take a look at some of the astounding technologies that have been developed in recent years and over the last couple of decades that help us better understand the science of the sun. And with that, we would like to introduce our first guest in the series. Our guest today is my dear friend and colleague, Dr. Madhulika Guhathakurta. She goes by Lika. She's a senior advisor for new initiatives in NASA Heliophysics Division. That is part of the Science Mission Directorate at NASA. For the past 2 decades, she has enabled the development of heliophysics as an integrated science discipline. And as the lead for NASA's Living with a Star program for 16 years, she made possible flagship missions such as the Solar Dynamics Observatory, also known as SDO, Van Allen probes, stereo, and many others that have truly revolutionized our understanding of how the sun shapes space weather in the solar system. She's been awarded numerous national and international awards, and she continues to, and has in the past and continues to champion the growth of FDL. Welcome to the Wormhole. So pleased to have you join us here today. And I'd love to start by asking you a real important question here. Lika, why didn't the sun, and why doesn't the sun have to go to college?
Because it's already it's got millions of degrees if you go to the corona. Like, excuse me.
There you go. You knew the answer. Most excellent.
Thank you.
Oh, of course. It's so good to have you here, and it's always a pleasure to spend time with you. We're going to cover a few different things in our time today. I'd love to start by asking you, because you've been doing this quite a while, and you are a fantastic example of a scientist, in my opinion. What was your science journey? How did you end up where you are today in science and just in life? What was your journey?
Interesting question. This is like asking a star what's its life cycle. I mean, it's circuitous, kind of like orbits of planets. You have a bump in the trajectory, you change course, you change direction. That happened a lot in my trajectory, actually. Haven't been completely deorbited yet, but jokes aside, I could give you a slightly longish answer to how I was inspired to
Please.
become a scientist that I am, an astrophysicist and whatever else we might ascribe to myself. Don't know. And how I actually fell into the study of sun. So basically, from a very young age, my fascination with astronomy, astrophysics began to blossom, fueled by the beautiful night skies of Kolkata. Without giving my age away, let me tell you, the skies were not this polluted back then, where I spent my early childhood, and I vividly recall the awe-inspiring moments, spent gazing at the stars from the terrace. A cherished memory, I suppose, that ignited my curiosity about the cosmos at that point, basically. And I remember that I would, even at that young age, drive my father up the wall with my question. These are difficult questions for anybody. Where do we come from? Where do we go when we die? I had lost my grandmother, who was very close to me. So these were very powerful questions in my mind. My father, who was a banker by profession, but he was really more a philosopher, a poet, a mathematician, he would respond with reason and logic. And I still remember, he made me draw a circle. And then he asked me, well, can you tell me now where the beginning or the end is? He was teaching a 6-year-old that some questions do not have answers without saying so explicitly, without shutting me out. And that circular form, perhaps in the shape of the sun, became the gravitational point of my career. So these are all sort of general answers. And I want to take time to explain this because I have so many young people who send me emails, ask me questions, and I want to take the time to say how I came to be where I am. So my father played a very pivotal role in nurturing me, right? Taking all the children to planetariums, movies, indulging in our endless stream of questions about the cosmos. And back then, I would be just excited by looking at comets and Saturn's rings. And as I reflect on those precious moments from my childhood, I realize how they shape my journey into science. Each encounter with the night sky was really fueling my determination to unravel. Like, what is going on out there? And I knew nothing. I didn't know the word astrophysics at that point. And then so, it's not up until my undergraduate years in University of Delhi where I began to study science and physics as a discipline, where I also armed myself with math and chemistry and all of that. And then during my master's...
And you could have just as easily gone into business or humanity, right? But you were this insatiably curious child who ended up in science.
It's a very, and so many people actually go to planetariums, love dinosaurs, look at the night sky. They all have that potential. That's what I'm saying. And we have to nurture that. So we need family, we need culture, we need society, we need universities without putting us down so that we can pursue that trajectory. And it's in my master's class, where I sort of took on the pursuit of astrophysics and cosmology. And that's where my journey began. And I left India, came to US to do my PhD.
And you ended up at the center of the heliophysics science community in Boulder, Colorado, which remains to this day the center of the heliophysics science community and space weather community in so many ways.
It's so true. And back then, I didn't even know Denver existed as a city and Colorado was a state. My knowledge of geography wasn't that great.
How lucky for us, the world, that you did end up there. Now, you don't, you sometimes call yourself a heliophysicist, but since I've known you, you refer to yourself in a different way. And if you could tell us a little bit about what you refer to yourself as today, and tell us a little bit about what heliophysics is, when it started to become used, and what is really the significance of heliophysics as a science? Why should we care about our sun if we can go out and just enjoy the sun on a nice sunny day? But let's start with, what do you refer to yourself as? Because I love it. I think it's just great.
Well, I mean, this event happened not that long ago, about 4 years ago. LinkedIn on International Women's Day really wanted me to write a piece, and I had promised them I'd do so. This is back in 2020, just at the crossroad of COVID. I had come back home and I realized I hadn't written anything. And I said, okay, it has to be kind of clever with the right amount of balance, because I just don't like to go off on saying we are not nurturing young women and kind of make young men feel sort of alone. So I started figuring out, how do I introduce myself? Where do I go with this, right? And I wrote a little synopsis on my own self and my journey. And the title was Heliophysics. It's a play on words.
Heliophysics. I love it. It's great.
Because heliophysics is a made-up word, I'll tell you that.
It personifies you, by the way.
Yeah.
It just does.
Is she who lives in a heliocentric world. Need I say more?
We certainly do. Well, it is heliocentric, and I think when we talk about that, you mean, you, as we mentioned in the intro, you were the lead on Living with a Star at Science, and we really do. And I'm not sure how many people have that insight where they look at our sun and go, "Oh, yes, that's a star." And not only do we live with it, we sort of live in it in many ways. So talk a little bit about that in the science of heliophysics. And, the sun's a big deal, but heliophysics is even more than just that fireball that we see up in the sky. Its area that it literally covers is significant. Tell us a little bit about that.
So, yes, let me actually address some of the, component part questions you had, right? So what is heliophysics? It's a made up word. Let's just start at the very beginning. When you're starting a new discipline, you don't have the luxury, and it's a connected discipline, as I will talk about, that to kind of go and latch on to something else. You have to create a word and define it. And so heliophysics is the integrated study of the sun, its planets, space environment around it, as a dynamic system. And it focuses on the sun's very turbulent magnetic activity and its effects on the upper atmosphere of Earth as well as on the, planets of the solar system and the surrounding heliosphere. So it encompasses many areas of inquiry, cosmic rays and particle acceleration, space weather and radiation, dust and magnetic field, reconnection, magnetic reconnection, solar activity, stellar cycles, aeronomy, space plasmas, magnetic fields and global change and the interactions of the solar system with our galaxy. It's everything under the sun, basically. But it is the magnetic field of the sun that dictates this interaction and is the most fascinating force which shapes the universe we live in, and that is the heliosphere. So, in a nutshell, heliophysics is a unique hybrid of astrophysics and meteorology. And now you know why it's so complex.
Now, we say the word heliosphere, and we're all familiar with the atmosphere, and some people are familiar with the thermosphere. And we know what that area is, what it encompasses. How big is the heliosphere? What does it encompass?
Oh my. I would rather someone does an internet search and tells me, but it's huge. Okay. So distance between sun and earth is 1 AU, and I'd say it's over 100 AU. And all boundaries are tenuous. Nothing is rigid. And discipline boundaries are not rigid, but that's what we do, right? We get hyper-focused. So the boundary where solar system ends, which is our bubble, which is the heliosphere, versus where the interstellar medium begins, it's a fuzzy boundary. And the two Voyager spacecrafts, as we speak, are navigating that uncharted territory to give us that information. So it's
quite phenomenal.
AUs. Yeah. One astronomical unit, distance between sun and earth.
Much larger than we would think of in our normal day-to-day activity when we think about the sun's influence. It's significant. It's a star. It's a star. There's a lot going on. So let's talk for just a minute about, before we take a quick break here, let's talk a little bit about some of the missions that you have been a part of, and really some of the findings that just in your career for the last couple of decades that were just wonderful aha moments for you when we started to have a little better understanding of our star.
Oh, well, I'll start with my first mission. It's special to you, like your first child. I can't tell this to my daughter. I have a son, SON also, who's my first child. It's not true about children, but missions, yes. And stereo was the first mission. And I was brought to NASA headquarters from Goddard, where I was actually a card-carrying scientist doing my own research to do the stereo mission. Stereo mission, it's a set of two spacecraft that essentially left the sun-Earth line. That is our vantage point when we look at the sun. And they went around kind of like Earth orbit, one leading, one lagging, giving us the first three-dimensional view of an heavenly object. Have you seen anything else in 3 dimension? You haven't. It gave us solar storms and delving into it, seeing the magnetic field sort of, twisted and torn, coming all the way to Earth. It gave us a 360 view as the spacecraft moved around the sun. So there was a moment in time, a period, when we could see the front of the sun and the far side of the sun at the same time, on the palm of our hand, basically, right? Because we created tools, iPhone tools, app, with which you could see what does the sun look like on the far side. So these are stereo just sort of revolutionized our view of the interplanetary medium. I started using the word interplanetary space weather. Space weather is not special just to our planet. With stereo spacecraft, we could actually see when storms are happening, coronal mass ejections, flares that are going to Venus or Mars or Mercury or Jupiter. We created models, right? And we could see the impact it's causing there, and we could measure them with other NASA satellites or other agencies' satellites. Stereo is absolutely phenomenal. Two tiny school bus sized spacecraft that has allowed us to view solar wind that we talk of. We can't touch it, we can't see it, right? But with stereo, we actually took images of solar wind. So it was no longer kind of something we don't see. We felt we are in it. I'll end there. There's just
What
too many.
what
So it's just
experience?
insane.
Feel like we're in it. Yeah. I love it. Well, we're going to do this. We're going to take a very short break right now. We're going to come back in just a few seconds. And so those of you tuning in, if you stay with us, we're going to come back and spend some more time with Dr. Madhulika Guhathakurta, NASA scientist, currently serving as the senior advisor for new initiatives in NASA's Heliophysics division, which is part of the Science Mission Directorate at NASA headquarters. Lika, we'll be right back with you. We're continuing our conversation with Lika. It is NASA has designated 2024 as Heliophysics Big Year. One of the things that is always interesting to me, Lika, is or are the people over the years, and I love knowing that you have collaborated with some of the and been mentored by some of the people who have helped us move ahead significantly in our understanding of the sun. If you could take a minute just to talk about a couple of them that would encourage other people to go and look into their story. I'll start because I think one of the good ones would be Jack Eddy. And he's become more and more in just the last few years someone that I've been paying a lot of attention to. But you've known these people, you've worked with these people. So tell us a little bit about a couple of the people involved on your journey.
I will most definitely do so. But I want to say this, in the beginning, that to create a new discipline to lead the Living with the Star program, it's a unique program in NASA history and remains so. It is really doing science, curiosity-driven science that is relevant to life and society. That is the goal. So, in general, truly too many to name. The field was created by a village of scientists and not few individuals. But you brought up Jack Eddy, and I'll bring few more.
Okay.
Jack Eddy was a pioneering scientist back in the 70s. He made the first connection between sun and climate. And for that, he was punished. No good deed gets unpunished, as the saying goes. I wish it didn't. And gradually, with time, people, and he did reading analysis to kind of get to this scientific aspect of that understanding. So he, to me, represented interdisciplinary science, and that's what we are. I told you how many different things kind of really compose the field of heliophysics. And so Jack Eddy actually, or rather, I worked with him. He was a consultant to the Living with the Star program, really advising and shaping this interdisciplinary science. When he passed away, in his honor, I started a fellowship called Jack Eddy Fellowship, and that happens to be the most prestigious fellowship in the heliophysics division, a named fellowship. We are always trying to kind of, admire the astrophysics name fellowship. There is a kind of little bit of sibling rivalry, right? So who could we name our fellowship after? And it's interdisciplinary science. So we have over 40 Jack AD fellow students. Some have become, they are mid-career, established career. They are someone or somebody in their field, not just in the US, all over the world. There are places in the world they started heliophysics department, basically, when the students came and studied heliophysics in our summer school. So, he and the textbooks that we created. So what's a discipline, right? I kind of gave you the components of a discipline to integrate this disparate science together into something coherent requires that we take students through really some textbooks, some guidance. That's when I started the heliophysics summer school with UCAR in Boulder, Colorado. And that's like back 2006-7 timeframe. And these textbooks were written basically very coherently. It is more reference books than textbook. There are 5 volumes now that talk about heliophysics as an integrated science. And I couldn't have done this. I wouldn't have undertaken this journey if I didn't have Professor George Sisko, who is no longer with us, from UCLA and then Boston, a renowned plasma physicist, and Dr. Carl Schreiber, also retired from Lockheed today, again, a solar stellar physicist. And together they created the marvel of the heliophysics textbooks.
Wonderful. People, it's all about the people. And by the way, I'm looking forward to when I'm telling, whenever I'm able to put you in the list of people that I talk about when talking about Eugene Parker or Jack A. and so many other people who've just done so many interesting things. So let's talk a little bit about the current state of heliophysics research, because speaking of that name Parker, the Parker probe, tell us a little bit about this very exciting thing that it's the fastest thing that humans have ever created. Tell us a little bit about the Parker probe and why it's important and what it's going to help us better understand about our sun.
It's kind of fascinating. So, sometimes I feel I stayed on at headquarters this long just to see that mission actually fly, which it did in 2018, and then give us the data, right, to really kind of see, was it worth it, right? And I can tell you in the beginning, I was having my doubt because the data we were getting, which is again close to 1 AU, or Venus orbit, where we have seen data before, and I was beginning to doubt, my goodness, we've spent so much money, so much resources, so much energy. Did I do right? Because I pushed it. I pushed it very hard. And now that we are getting the data from the close encounter, the perihelions, every successive Venus gravity assist takes us closer. And in 2024, December 2024, we are actually going to achieve the closest distance, which is close to 10 solar radii from the center of our sun. And the observations we are seeing, because we have to write books about it, how can I give you an answer, right? It's absolutely breathtaking, amazing, some of which is verifying some of our old ideas, some of which are discarding our old ideas. Some of the things, the wave particle interaction, the tying in of the magnetic field to the surface of the sun, these are things we haven't seen, and therefore we haven't thought about how to address them. At the end of Solar Probe, in the next 5 years, we are going to rewrite textbooks of how a corona, whether solar or stellar, is heated, and how particles like solar wind gets the momentum to shape the heliosphere.
It's one of those things that was a mystery for so long about the sun that we're just now starting to understand, isn't it? The old, if you hold your hand close to the surface of the sun, it's, of course, very hot. And if you did that to a campfire and pulled your hand away, it would get cooler. But on the sun, if you pulled your hand away, it would get even more hot as you did
Basic
that.
law of thermodynamics. Corona defies that. But then what? How does it get heated? How does it energize the particles? Lots
And whenever
of fascinating observation, lots of new kind of understanding have been reshaped by actually seeing the data, both in situ data, so you're locally actually measuring the environment of the sun. When we have looked at the sun in the past, and we still do, it's remote sensing observations, which are imagers, but you are doing line of sight integration, right? 93 million miles. There could be lots of stuff in between. And we have to import that data to get information. When we have flown in situ observatories like Ulysses, that would be at 1 AU to 4 AU. So you're not anywhere close to the sun. Everything has been simplified by then. And so we said, we need ground truth observations. And this spacecraft is actually like a probe, taking the temperature, measuring the magnetic field, determining the pressure in sun's environment. Touching,
and doing it while
tasting,
traveling,
smelling.
and doing it while traveling at 500,000 miles per hour currently.
Yes. So,
Crazy.
I want to add another thing, because we so rarely get a chance to talk about what heliophysics is. So Parker Solar Probe is the closest mission that we have sent in our solar system. And Voyagers are the most distant. Think about it.
Interesting. Yeah. I hadn't until just this moment ever framed it that way. That is really interesting to think that way about it. Wow. What we've seen in our life. My goodness.
And there was a time when I was the Voyager program scientist. I was the Voyager program scientist, the first Voyager program scientist in Heliophysics division when Voyager came to our division.
Wonderful. So you've been on, you've managed to be involved from one end of the sun's influence to the other end of the sun's influence during your career.
That's an interesting way of putting it. I had never thought of it that way.
Yeah, I love that. That's great. Well, we only have a few minutes left, and these days, of course, our collaborations that we're involved with, that you have been a part of, I would say not just a part of, but you are truly the founder of Heliophysics at FDL. It was because you got involved at FDL that Heliophysics even became a thing, and continues to be a thing to this day. We're currently working on the 2024 Heliophysics research, doing amazing things with data. You mentioned that about the Parker Solar Probe. We're doing and have done amazing, truly astonishing things with SDO data. So it's wonderful to look forward to all the things we have in the short-term future that we're going to be able to do. And we'll talk more about some of those in future wormholes, specifically adding yet another layer to that interdisciplinary approach to discovery. In this case, through FDL, it's through AI and ML that we're doing that. But when we think of the longer term of heliophysics and some of the things that you can imagine that we could do and perhaps should do as paths in research for heliophysics, what comes to mind? What would make you truly happy to know that we have pursued and perhaps discovered in the future of the science of heliophysics?
Yeah, worth pondering over. If the ultimate goal of heliophysics is to support space exploration, let's just champion that goal, right? It is everybody's goal. in the space agencies. Then I would say that we have to understand the meteorology of space. And I choose these words with a purpose because everybody understands meteorology in Earth and what we have done in the last 40, 50 years. So, if human species would like to go from being earth dwellers to spacefarers, then we have to have the knowledge of meteorology of space. You can call it interplanetary space weather, you can call it heliophysics, call it by your favorite name. The game is the same, really. And that understanding will eventually lead to mitigation strategies. And in my current role, I want to add one more thing. How do
Please.
we do this? It's not just missions, right? So I am now exploring, as you have kind of already mentioned, Frontier Development Lab, AI. I'm exploring the intersection of heliophysics with cutting edge technologies such as artificial intelligence, machine learning, and leveraging these techniques, we are unlocking new insights into solar phenomenon, into solar sun-earth connected phenomenon, and advancing predictive modeling, which is very important for NOAA, for space weather forecasting. And so this convergence of traditional heliophysics with emerging technologies, with the amount of data we have over decades, space-based, ground-based, it is truly astonishing, and it just scratched the surface. And by the time we have scratched the surface, there are new tools coming on board. So keeping pace is a little bit dizzying, and
I
not a lot of
always
resources always.
I've always appreciated your outlook on that and thinking about possibilities and your engagement over the last 7 years on these rapidly accelerating technologies and new technologies that come along. I can absolutely imagine the 6-year-old Lika um, not being very much like the Lika that I know today with regards to curiosity and really knowing it's okay to say, I don't know, as long as we follow it up with let's find out. And you've always been a let's find out scientist, and it's been great. Well, it's been absolutely great to have you. One last and final thing: what inspiration would you like to share with up and coming scientists, or even people who've been doing it for some time? But we specifically in FDL, we work with postdocs and early career scientists often, and as you said, with the Jack Eddy fellowships, the same kind of thing. What would you, one piece of advice that you'd like to share with people with regards to their science journey?
This is what I'd like to share. You know, while all my life I have been into extreme science, even though my father wanted me to do fine arts with math, I was very good in math. That was a given. But I used to sing, I used to paint, I used to do these things, and he thought that would be a great combination. But you know, I chose to do science. And I've come to realize that pursuing STEM should not happen at the expense of other disciplines. And as in all things, I think a fulfilled life is one of balance. So, you know, one's sort of dogged pursuit should by no means shadow one's efforts in experiencing the vast richness of other human resources. And one may often hear people, you know, dismiss these pursuits as unworthy, right? Or soft because they lack technical rigor of the STEM disciplines. And I'd say never make the mistake of giving up your passions for STEM, but integrate it. You know, the greater your exposure to all human intellectual pursuit, the more robust both your life and your science will be. And I'd like to kind of end with a quote from my favorite poet, philosopher, perhaps guide, Tagore. who so eloquently put it, right? A mind all logic is like a knife all blade. It makes the hand bleed that uses it.
Wow. Fabulous. Thank you. What a perfect way to wrap up things in our time with you today. Thank you so much, Lika. It's always a pleasure. I'm certainly looking forward to all the future collaborations that we'll be doing for hopefully a very, very long time to come. We appreciate you and your mindset. Thank you.
Thank you very much for having me.
Of course. And thank all of you for joining us here. We're grateful for you taking time out of your day to take a listen and join us in the wormhole. Please take a look at trillium.tech/wormhole for our upcoming interviews in this series, to more fabulous guests, and you can read about them on the website at that link. Thank you all for joining. Okay, we are back for the Q&A session. So if you are currently watching, don't leave just yet. We're going to spend a few minutes here with Lika and let you ask some questions. And we're going to do that by inviting Catherine onto the stage. And she has been going through the list of questions. Since we don't have time to answer all the questions, she is going to pick some out, and she will read your question to Lika. And we'll hear what Lika has, what her response is. So, Kat, thanks for joining us. And why don't we go ahead and get started with the first question?
Thank you so much, Jonathan. The first question comes from James Power, actually. And he's asking, how can we close the gap between research and application in science? And not just Helio, but all NASA-supported science where decisions are the endpoint.
He doesn't get to ask a question. But I will
It is a good one.
try to answer in that I think we are already pursuing this. It's matter of balance, right? NASA is sort of about developing new missions, new rockets, new aeronautic airplanes, all of that. And in that, sort of the fundamental research side of things get shortchanged. I mean, I'm sorry to say, but that's how it is. It's an agency that is in the pursuit of technology, and technology that allow us to get these insightful observations. And so what NASA is doing today is trying to look at its portfolio. Every division does it in its own way. In the heliophysics division that I'm part of, I will say they have been pretty bold. I'm not going to say that our RNA budget has gone up significantly, but even within that small budgetary framework, because it's just a small fraction of our total budget, we are carving out areas that we believe are very important for future. It's called seed funding. And the growth of AI ML is one such area, for example. So sometimes we program scientists, discipline scientists, have a role to play in communicating to our leadership why this is important, what have we observed, how can we change the balance to move forward. I mean, this is just personal experience. That's what I can share. I am not right now creating the management tool of figuring all this out. But even as individual scientists and managing different programs, we can be cheerleaders, and not just cheerleaders to be cheerleaders, but actually expose the importance of such areas.
Hmm.
I don't know, James. I gave you an answer, so you should be happy.
There you go. Be happy, James. Okay, Kat, do we have another question?
Absolutely. Great questions coming in. This one comes from Martin Sanner, and he's asking, given the current developments in, for example, AI or technology in general, but also the upcoming missions like Punch, Smile, and Vigil, what do you think is the most exciting direction for science emerging from them, and why? And this does include the mix between currently emerging platforms combined with future platforms.
So I would say that, Vigil may be still something we can do something with, right? If I look at Punch, I happen to be Punch program scientist. Things get kind of baked early on. Each one of these missions take a long time to develop. I kid you not. I've been there and I know. So bringing in anything new that doesn't have heritage will itself cause a problem. I mean, we are going to an environment called space. It is about as dangerous as anything can be. And so we don't like to take chances. We have been given to spend taxpayer monies, right? We are spending money on your behest to bring you back science, knowledge, mitigation strategies, and that's why some of these rules exist. But what I could say that for future, it is not just essential. I feel that it has to be mandatory that we integrate our knowledge of AI, autonomy. That's another area NASA is very much engaged in. Radiation. How well will our computers, chips work in high radiation environment? That we must have sort of technology demonstration missions, perhaps, that integrate these concepts, right? CubeSats, suborbital rockets, all of these kind of demonstrate technology that feed into the larger missions eventually at NASA. Similarly, we have to create those pathways, right, where we can do technology demonstration to integrate this kind of knowledge for future spacecraft, for future telescopes, where we have demonstrated, you don't need 10 filters. You could do the job of 10 filters with 3 filters. That's reduction in cost, mass, all of that, right? There's compression tools that we are beginning to, that's more easily integratable. So these are being thought through. It's an amazing
Okay.
time.
It certainly is. Thank you for that answer. Kat, I think we have time for one more question. Maybe more if we have some more, but one more for sure.
Actually, we have 2 questions.
Well,
Actually, the next one does come from James again.
Good.
And he's asking, can we do a solar sail race around the solar system? Is there enough variation in the solar wind to make this analogous to ocean racing?
Well, James, I can always tell you that you are so imaginative and you will come up with the cleverest of ideas. The concept of a solar sail mission has been in the books of heliophysics for a long time. I'll say at least 20 years. There was one mission that almost got selected from Jet Propulsion Lab back in the days. There's still work going on. There was another one almost ready to launch. So you know that there is maturity of technology and political willingness to try. Resource is always a problem. And so it hasn't happened yet. But solar sail is a reality and it's getting better with technology. One of these days, probably we will see such a mission, and there might be one happening right now that I don't know of. I don't know of everything that's going on at NASA, especially with COVID, since we are no longer sort of occupying offices at headquarters, Goddard. Your interaction with individual scientists, engineers are very limited. So the information that used to be kind of, passed on almost via osmosis, chatting in the hallway doesn't happen. So it's possible there is such a concept. Regard to the race, well, why not?
You know what I like about the race idea? You think about what things like the America's Cup has done for maritime innovation, because you have people with significant resources putting the resources into advancing that world significantly. And wouldn't that be great to advance science that way?
So it is. It's mentally, and science is, we shouldn't be thinking doing science just through agencies. As you have seen in the world of rockets and taking payloads, agencies and the private sector are working hand in glove, right? So we have so many rich people in this world. Any one of them could fund such an idea.
I
Why does
love
it
it.
have to be NASA just doling out its very few limited research dollars?
I love the idea of the Solar Cup, just like the America's Cup yacht race, except this is the Solar Cup. Wouldn't that be fun?
You
Okay,
guys could champion this. I give it
there
to
we,
you.
okay. We'll have you fire the starter pistol. How's that when it kicks off? Kat, I think we have time for one more question. Do we have another question?
Yes, I'm really happy we do. We have an amazing question coming in from Bhagyashre. I hope that I said that name correctly. And they're asking, how do you think the advent of AI ML affects the way students learn? And how well prepared do you think the next generation of scientists will be?
Well, that's a lot of thinking. And I think, early career students, postdocs would be in a better place to answer this question in terms of how they are being affected. The ones I encounter in summer school or at FDL, what I find is that they have everything at their fingertip, which I still to this day do not. The searching mechanism, the querying mechanism, it is so incredibly powerful. And because we are continuously evolving this large scale model, we can be more precise in our questions. We always don't have to be bogged down by getting thousands of responses, a lot of which might be wrong. And I think integrating, so to me, computer science, AI, maybe Python is the language of the day to day. These should be like a natural language course when you're going through high school and then in college, to really integrate this in the education so you can get the most out of what is out there. If I had more time, I'd be spending time on the internet, which I have not done in my life. So I know so little. I don't know jokes. I don't know entertainment because I spend a lot of time kind of doing this sort of work, thinking about programs, creating science, thinking about science. But each one of us could kind of harness kind of the essential things we want from what's already out there and use it for the right reason. Make AI shine and not let us be afraid of it. It's up to us as human species.
I appreciate your wisdom. And speaking of shining, Lika, when we met many years ago, your hair didn't look the way it does today. What's going on here? What's happened? What have you ascended to? What have you become?
Well, Perhaps I'm trying to blend into the corona. I mean, look at that pearly halo of the corona. That is my thing, right? And my hair incredibly matches that.
It's
It's years
amazing.
of, you gave me an opportunity, so I say years of wisdom oozing out and blending into the corona. How about that for an answer?
That's a
I think
great
I was
answer.
always this white for at least good 30 years. I just didn't know.
Well,
Then he prevented me, so I colored my hair.
I love it. And I sort of, when I see you in person, even just last Friday when we were together in person, when I look at you, I can't help but see that image that I'm looking at on the screen right now. It's you. It fits you. It suits you, as we say. So well done. You've definitely become one with the sun, more so than ever before. So, well, thank you for being with us and taking some time to answer some questions. We are certainly grateful, as we said before, to have you, and looking forward to many future collaborations. And we'll have to have you back on Wormhole in the future and do an update later this year on the state of heliophysics science. Thanks, Lika.
And I want to say thank you to you, Jonathan. I think you certainly made it fun. I hope
Oh,
so.
we did.
Others
And
believe it.
we
It
need
was
to
fun
share
for me.
with our friend Scott at Google that it was fun. You said, I can't promise to make it fun, but in fact, you made it fun. So thank you. Good. Okay. Thank you all for joining us who have, and we'll look forward to seeing you at the next Wormhole. For more information, go to trillium.tech/wormhole. That'll be in the comments here. Kat's going to paste that in there for you to see. Thanks for joining. We'll talk to you all soon. Be well.